I'm going to take a look at two quick limits here that have e to the x's present. So in this case, take a look at the limit as x goes to infinity of x over e to the x. Remember, when we have a fraction, we can look at both the numerator and the denominator and see where they go. Numerator is going to infinity. Denominator, going to infinity. Infinity over infinity, indeterminate form. Remember, indeterminate form is infinity over infinity. So we have to figure out what more can we do. And this is where we use L'Hopital's rule. So if we apply L'Hopital's rule, what we get is the limit as x tends to infinity. Remember, L'Hopital's rule says I take the derivative of the numerator, that's 1, the derivative of the denominator, e to the x. Now, L'Hopital's rule is extremely useful with these cases. So when we saw L'Hopital's rule in the past, we had these x to some powers, and we had lots of polynomials. It's cool, but we had other techniques for that. But L'Hopital's rule is almost the go-to one when we have things like e to the x's and natural log of x's and these other functions that go off to infinity, but we can't divide by the highest power of x anymore. So here now we take the limit again, the denominator goes to infinity, we have 1 over that, which ends up going to 0. So if you remember, I mentioned this a few videos back, that what we're really asking with a limit of a fraction, if they're both going to infinity over infinity, we're saying which one's going to infinity faster. If the top's going to infinity faster, this whole limit's going to be infinity. If the bottom is going to infinity faster, then the whole thing is going to go to 0. If they're going at roughly the same rate, it's going to approach a constant. Here, the denominator goes to infinity faster. And we can see that graphically because e to the x looks like this, whereas y equals x looks like this. E to the x is getting to infinity a lot faster than just x's. So that's the intuition behind why this limit is equal to 0. So here now we have the limit as x approaches infinity of e to the x divided by natural log of x. Both of these go to infinity when x goes to infinity. So I do L'Hopital's rule. This is now the limit as x goes to infinity. E to the x, the derivative of e to the x. Derivative of natural log of x, we said that's 1 over x. So what this now becomes, if we want to check this at this point, e to the x that goes to infinity, 1 over x is going to 0. 0, okay. Now, infinity over 0, that is not an indeterminate form. Infinity over infinity or 0 over 0 is, but infinity over 0 is not. We can figure out what this limit is equal to. Because what's happening is that when you have the numerator going to infinity, it's getting really, really, really big. When the denominator is going to 0, the whole thing is getting really, really big. So these are working together to shoot off to infinity. Now, positive, negative, these are both positive numbers, so this is going to positive infinity. So you could just call it at that point and say, great, or you could rewrite this because you know how to work with fractions in the denominator. Right? This is the same thing as the limit as x tends to infinity of x times e to the x. So move that up top. Now I have infinity times infinity. Those are just shooting again off to infinity. So I have infinity as my answer. So these are my limits using L'Hopital's rule.